to transfer the dimension like this. These are the two views. Transfer the lines from these ends. Draw a line which makes an angle of 45 degree with this XY line, and transfer the lines from this view to this view, and when this cuts this meter line, from that draw a straight vertical lines which intersects over here, and here in this way also we can transfer the dimensions. The first method is to transfer the dimension with the help of scale and measurement, and the second method is to transfer the dimension with the use of meter line like this. You can see here views are too close, right? So whenever you draw meter line, you should take care about this distance. Meter line should be drawn little bit on this side, or by thumb rule from this corner, so that whichever distance is maintained over here, that would be automatically maintained over here. So it should be drawn little bit away like this. This meter line should be drawn little bit on this side, then transfer the projections from here and draw it side view by taking projections from meter line to here, and this is the view, side view of this object. So this is a good practice to use the dimensions in another view. Now basic dimensioning, a very important topic of present discussion, that is basic dimensioning, how to use the basic dimensionings in that object. Components are shown over here. These are the components of dimensioning: extension line, dimension lines, leader lines, dimension numbers, and local nodes. The first is the extension line. What is extension line? So for that, transfer it from here. For example, this is the center of this circular hole and this is the edge. So these two lines are called as the extension line. So this is also called as extension line. This one, and this one. All these lines are called as extension line. They should be drawn a little bit lighter than the lines drawn used to draw this object. They should be slightly differ. Then second is the dimension line. This one, these arrows shows the dimensions. These lines are called as dimension lines. This arrow should be drawn, a very thin arrow should be drawn at the ends, and in horizontal and vertical arrows may be used as per the need of the parameter dimension. So that is second one. The third one is the leader lines. What do you mean by leader line? It is drawn like this. The line which are used to take dimension outside the drawing. These two lines are called as leader line, which are extended from here on this side. The fourth one, that is dimension numbers. You can insert the dimensions of parameters like this. Here 10, 27, 43, 17 and so on. That is dimensioning the numbers. And the last one, that is local nodes. Whichever nodes are there, or whichever important things which needs to be right over here, that is called as local nodes. They should be written like this: 10 drilled 2 holes R16. What does it mean? It's a drilled hole having 10 mm diameters, and such kind of 2 holes are there. And R16 means the radius of this arc is 16 mm, and this is the center for that arc. So I hope all these components are clear to you for dimensioning and in orthographic writing. Now next, tangency and intersections. What is tangency and how intersection lines are to be used? No lines is formed when curved surface tangent to a plane surface. It's very important thing. Try to understand this line. And second is, line is formed when curved surface intersects a plane surface. It looks somehow jumbling words, but with the help of this example it would be clear to you. If this is an object right? Here curvature is there. The curved surface here is tangent to this plane surface. So here line will not be generated. Here lines will not be there. Like this. If these are the three views of this object. So here tangent is there. So here line will not be there. No line is there as shown over here. And here also tangent is there. So no line is here. So this is the meaning of first statement. And about second statement, if this is the case, so line is formed like this when the curved surface intersects a plane surface. Here this curved surface intersects this plane surface. So in this case, you can think about these two views, top view and side view. So here intersection is there, so line will be there. So here full line is there. Similarly, intersection is here, hence line would be here also. So these two lines are also to be drawn because here curve portion intersects a plane surface. Here the curve portion is tangent to the plane surface, so line is not formed. Now next, this is an object. Think about this object, where the line will be there or not. Is there any line or not? Think about this. Here tangent is there, so no line. Here also tangent is there, so no line. But yes, here corner is there, right? To represent this corner, we have to use a line over here, like this. Tangent, tangent. Here also tangent, and here is intersect. So this would be line. One line only would be there. Only in this view, here line will not be there. So for this object, think about the lines. This is taper inclined line, so no any line is here. But in this case, this is a straight vertical line. So what do you think about this? If you look from the top, this edge would be visible to us. Hence, line would appear in this case like this. In both the views, in side view like this, and in top view, here is the plane. So plane will be visible in top view as a limiting element or a line like this. So this is the tangency intersection of the curved portion. Now about this object, think for this object. If this is an object, these are the two views. Here intersection is there, so that intersection is to be represented by full line over here, and here outlines are drawn. To draw its side view, draw meter line, take projection, and this is the side view of this object, right? It is drawn like this. You can understand how it is drawn. Now for this second object, this is an object, tangency is there, so no lines would be here because both are tangent. So here vertical line should not be drawn. Meter line, its side view is drawn over here. This would be its side view. Here also this full line represents this edge. And now fourth one, this one, for this object, draw meter line, take projections, draw here lines, and from here also draw line. This would be its side view. This is an object, and the fourth object is drawn over here. Here, yes, you can notice here this line is tangent to this circle, and this line is also tangent to this circle. So in both these cases, the line will not be generated like this. So this is the views for this object, front view and top view. So in all these four objects, you can identify the difference where the line would be formed and where the line will not be formed. And this is the side view of this object. It could be drawn like this by taking projection from front view to meter line to this side view. Now one quiz showing some important aspects which we have discussed today. First one, which should be the natural position of the light bulb, A, B, C or D? in which we can draw easily this object. Yes, this A is the best representation of this object, and hence this A size of object should be drawn. Now think about this one. Which are the necessary views for this object? ACE, AC and E, EBD, E, B and D, EA, E and A, EC, E and C. Think about which views are necessary to represent this object. You can see here C, E and A. Two views are necessary, this E and A, and hence C is the right answer. Because in two views, if you look from E and A, all major parameters are visible to us. So these three holes are visible to us in A, and in E this shape is visible to us. Now third question, which is the correct first angle projection method? Four objects are shown. You think about in which case the first angle projection method is employed. Let me discuss one by one. The first is this one. In this case, this dotted line is drawn. So in first angle projection method, this edge would not be visible to us. So if you look from here, this would be dotted line, this is dotted line, and this is also dotted line. So this could be the first angle projection method. But here, think about these lines. These are visible, these are visible. This bottom is visible and this circle is visible over here. If you look from the top, if this is below side, then this will not be full circle, and hence this is not the first angle projection method. So A is not the correct one. Think about B. If you look from the top, this is visible, so this circle is visible, hence this is correct. So it may be first angle. But think about this side view. Here dotted lines are there and this portion is here, so this B would be the right answer, right? Because this B represents, sorry, yes, we have discussed up to here. So we have discussed about this B, this we have discussed, this we have discussed, and this, yes. In this case, B is the right answer. B is drawn as first angle projection method. Now next question, which is the correct third angle projection method? Here we have to find out in which object the third angle projection method is employed. For example, say we think about A. If we look from here and this circle is drawn over here, so here it may not be the third angle projection method. Think about B. Here is the cylinder, or this extended portion is there. Here it is visible, so this is not third angle projection method. Think about this one. We are looking from top and this cylindrical portion is there, which is visible over here. So this is also not a third angle projection method. Now remaining A and D. D is the correct answer. In a D, it fully represents these all three views are drawn in third angle projection method. Now fifth one, which is wrong third angle orthographic view? In these four cases, which one is not correct or which is wrong third angle orthographic view? Think about first one. This is the object. If you look from the top, it is drawn over here. So top view is drawn above and front view is drawn below. So A is the third angle projection method. So A is not the answer. About B, if you look from the top, it would appear as shown over here. If you look from here, so this B is also not correct. Think about C. In C, if you look from here, then this view is shown over here. This is full circle, this is dotted circle. So this dotted circle is here, hence this is drawn with first angle projection method. So this is the wrong third angle orthographic view, right? So C is the right answer. Now for multi-view orthographic projections, box theory is employed. Now what is box theory? Let we take some practical examples to represent this box theory. In the projections, we imagine the object being drawn in the center of transparent box like this. This is the box which is inside the center of the transparent box, and the different views of the object are projected on the sides of this box like this: 1, 2, 3, 4, 5 and 6. So these are the 6 views of this object. One of these views is considered as the front view of the object like this. If you look from here, this is the front view as shown over here. This is front view of this object. Now this is the side view. One of these view, you can say select this view as a front view also. Of course, the front view of car is this side, but in the drawing of car, in the drawing of multi-view representation, we can select this view as a front view like this. This may be the front view. Based on selection of front view, other views are placed like this. If this is the front view, all faces of glass box are opened in such a way that all the views appears in the same plane like this. Open all the views, and then all these planes, all these views would be visible in the same plane like this. All 6 views: front view, 2 side views, top view, bottom view and rear view. These other views pivot around the front view. So in all the drawings, front view is at the middle and rest all views are pivot around its front view. These are the 6 views of this object as drawn over here: front view, 2 side views. Among these 6 views, we will choose those views which gives more description of an object. We need not to draw all these 6 views. The views which are not giving much detail, they should not be selected to represent the view. For example, in this case, these 2 views, this one, bottom view is not needed, so we should trim this. Similarly, this view, rear view is also not important because front view is there, so that we can erase. Similarly, from these 2 views, this view is not important, so we can erase. So these 3 views are enough to represent this drawing. 3 views are usually enough to portray an object. This is